This is David Mamet of Lottodds and Match 3 Colors. It is June 29th, 2024. Okay, I want to first go over some things here to start. Asterisks pertaining to the filters on a mobile page and auto predict. And also the all option we added to the mobile page. Revised pairs filter, I'm going to go over that. Binary code filter we're creating. We're going to create and release that to you in auto predict. It's pretty cool. I'm going to show you what it does. Then I'm going to just go over the mobile app, and then something really important here. Quantum filter. We're going to create. I'm working with a physicist I hired. Okay, he's a PhD. He is working at a college as a professor of advanced physics. So I hired him to create this, okay, this filter. We're going to see if this is going to help us reduce the numbers even more. We're going to utilize a method that we're already using successfully on Lottodds and try to apply it on with the quantum filter with qubits. And if it works, oh boy, this is going to be really incredible. And then AI, okay, just mentioning it here. AI, you know what? I'll mention it at the end, what we're going to do with AI. It's going to help you great deal, all right? So let me show you with Asterix. Asterix basically pertains to when there are, because we deal with the pairs here, right? M3C dictates what the color is going to be for both sides, right? So if the pairs are here within the green zone, it's going to get green. If it's in with the brown zone, it gets brown. If it's in with the red zone, it gets red. However, when you go into the red zone, a lot of times the pairs, if you deal with like say 11-3-1 or 10-3-2, the pairs may not come out. I've seen them not come out for a year. Okay, so we can't keep all that data in here because it'll slow down the page, it'll create lag time, even freeze up the page. So we came up with a solution. So we have a default, right? A red zone default. Okay, anything that's beyond what we normally correct is going to fall in the red zone default, and you can easily know what it is because you'll see here like this. They'll have no draw counts in them. Okay, meaning they're beyond the data collection that we do. Okay, so you see them like this. And what we have done is to, so you'll know which numbers they are, we have put an asterisk next to them. Like, let me see if I could find some here. All right, let's see if I could find some here. Like this. When you see asterisks here, they're in the red zone, right? Red. Yeah, red zone. So you'll see asterisks like this, meaning the front pair, right? Because M3C dictates if it gets asterisks or not. So it's in the default, right? It's out of the data collection that we do, so that's why it gets that, okay? It gets the asterisks, and you'll see them, like again, you'll see them like this, okay? They won't have any draw counts in them, like that. And you can do, when you go in the mobile app here, you can actually do searches on them and catch them. For example, if you do like triples, something like that, triples is brown and yellow. That's the only way where triples are located. So I'm going to do all the states, right? So this one here is all state. Grab all the states. So excuse me. Let's go back there. Okay, so let's see all the states now. Anything with that? Hold on. Bear with me one second. I want to isolate this because you want to isolate the red. I have, if you don't isolate, you're going to be playing with green, brown, and red. So remember, the asterisk is in the red, so we're going to isolate the red. Okay, and it's actually yeah. Hold on, right there. Let's get all the red. Whoops. So here, when you're selecting them, you see you got the black border. When you select them, it becomes a white border. That shows you selected them. All right, so now we can go here and triples, and let's do the first one. Then we can do a second one if we don't get any hits. And we're looking for asterisks. Grab them all there, and going to click that. All right, so there. So there's no asterisks here. Here's the triples, right? It shows you just two states that they have triples, right? For red zone. But we want to find asterisk. So let's go yellow, and let's grab that. And there you go. It'll show you the states that have asterisks. So for yellow, you have more triple numbers for the states, but few numbers you see here with the asterisks. Let me see if I could see if I had a state down here. Just asterisks. No, I don't see one. No. All right, whatever. Yeah, a lot of these you could just get rid of like that on your own. I'm not going to go through this because it's going to take me too long. But you see just a few asterisks here. See that? That means they're out of the zone, okay? Like I just showed you. All right. So, all right, so asterisks and all options, right? All options, what we did. Remember there was a button here that converted these to all like this? It was confusing some members, you know, rightfully, okay? Rightfully so. So what we have done is we got rid of it and we just put it here logically. We put it here. So if you want to view all the hit and miss, you just keep it all. If you want to reduce it and just look at one at a time, you just pick the one you want to view, and that's what we've done. And it helped clear up the confusion. All right. Now, let's see here. Revise pairs filter. Okay, here. Okay, so there was an issue with when you picked one and you tried to pick another one, the second one would override the first and it'll only show you the second like that numbers. Now you can just pick them, okay? And it will add the numbers on top of each other, okay? So if I go like this, got 10, and if I go that like that, there's none there. I go like that, there's none there. So if I add, keep adding, here's 11, see, and keep adding. All right, keep adding, 14, see that, 15, and I've got them all. It's not bad. Miss, hit, pink, singles, only 15 numbers. All right, so let me refresh this page. All right, so next is the, all right, this is pretty cool. Okay, all right, I want to first show you how these numbers can be reduced, okay, drastically. And then I'm going to get to the binary code filter, which I want to add here for you guys. It's going to reduce the numbers more. So if I look at something like this, yeah, I want to let you know something here. When you see the pink here that came out a lot, and then look at this run. 822, 822, 822, 822, 822. You see that? And for a while, it did not come out down here. Look at that. It did not come out for a while because they changed either the balls, machines, whatever they use, the Texas balls, machines, or algorithms. Okay, this column here, the pair sums, will always catch them. Will always catch the state lotteries when they change something, either the ball machines, the ball machines, or the algorithm. It will catch them through here. So the best thing to do is when you see the shift and these pair sums coming out, the colors, then you start playing those colors over and over. Like, look, the brown was coming out a lot. See that? The brown, look, it's hitting, right? Back to back so many times, right? But the pink wasn't. Then all of a sudden, they changed something, right? And then all of a sudden, it starts hitting like crazy. Look at that. 822, 822, 822. Definitely, they changed something. Look at that, right? Like that. And then you could play them. Look, pink started hitting like crazy. Yeah, because they changed something. So pair sums could uncover when the state lottery will change either the balls, the lotto ball machines, or the algorithms. Okay, so pay attention to that. All right, and always follow the colors when they change. So for example, if you're going to look at an overdue color, also pay attention to whether or not they changed something, the state lotteries patterns. So if the pinks are coming out back to back, like you play the pinks. If the browns are coming out, you play the browns like that. Okay? And you look what's overdue within the pinks or browns. Now, I look at this, pinks are coming out a lot. I'm going to say the pink would come out again. I'm going to look at here, miss, miss, miss. I'm going to go with hit here. There's only two hits on the left, hit, hit, and hit, miss. So let's see what we can get. I'll go with singles. Let's say, for example, singles. You got 27 numbers there. Okay, if I isolate singles, Let's see what kind of pattern they're showing me. All right, singles here. I got 2s and 3s and 4s. If I go 2, 3, and 4, all right, I've got 10 numbers only right there. And then if I think a green may come out, or red is overdue as well. So anyway, you've got 10 numbers right there. Okay? Now, and let's see the other one. Let's see the hit and miss. Wow, look at that. No numbers. This is your play. Look at that. So if pink would come out next draw, okay, we're looking at, and when I say next draw, it would be like the morning draw, okay, for June 29th. All right, so if it comes out hit with pink, okay, if it comes out pink, it would be hit. Let's see the other ones, okay? Let's look at all and then see what's in the other patterns. Nothing. Look at that. There's 2. There's 2 with a miss hit. So you have a total of 12. Wow, look at that. Only 12 numbers. So if pink comes out with this single and you have the quick pick column, 2, 3, or 4, okay, it's going to be that. If it comes out with a 1, let's see if it comes out with just the 1. What would we have if it just comes out with a 1? Okay. I'm going to choose 1. And you'll see the 1 here. So it's 17 numbers, 17, 18, 19, 20 numbers like that. You see? Okay. But look what hits the most with this. Yeah, 1 is overdue and it could hit next. But look what, you know what? Let us really look at the true pattern. And when I say true pattern, we need to isolate the pink, right? That will give us the true pattern, what may come out. Isolate, isolate, isolate. You have to isolate to be able to see true patterns with these. Okay, and once I've done with this, I'm going to show you the binary code filter, which is really cool, added to this. And it's going to get them lower than 10 numbers. All right, so here we go. Here's all the pink together. Look, you got 822, 822, 13, 822, 822. All right, and then here the 1 was here, 1 was there. 111. 1 comes out quite a bit with 822, pink, I should say. 822 came out twice back to back. Could it come out 3 times? Yes, it can. Now, and we're looking at singles, right? We think singles is going to count. Let's do singles. All right, so singles. Well, look at this. Look at this. 822, 822, 822, 822, 1, 2, 3, 4. So if a single is going to come out, then we're going to look at 831 and 813, 831, 813, and we'll look at 1 came out, 1 came out here. 3 is overdue. A lot of 1s. But I would say could be high probability you're going to see a 2, 3, or 4 here. 40 hit here. It doesn't hit much. Actually, hit there. There, not really that much. It already hit here. Could probably be seeing a 3 coming out here. But I'll do 2, 3, 4. Leave out 1, probably. Right? And then you would have 10. So let's go back there. So I'm going to talk to you about the binary code filter right now because we're going to be dealing with just 10 numbers here. All right? 10, 11, 12. But if you think it's going to be a hit just for this example. All right. 10 numbers, right? And these are the filters you're working with. If you think it's going to be a green that's going to come out, you could just go like that, that, and that. You lost 1 number there. And if you think it's 3 and 4 came out, if you think it's going to be 1 and 2 come out here, you've gotten still 9 numbers. Okay, that's a solid 9, right? All right, now watch the filter that we're going to put in here for you, which is pretty cool. All right. All right, here's the filter that we're going to be adding. All right, it's going to be on the auto predict page, auto predict, right? And the mobile web page. All right, so like this. All right, so it's going to be added like this. All right, and it's going to have color filter. It's a bits, okay, bits, because binary codes are bits, and under that are qubits, okay. And I'm going to talk to you about qubits in a minute. So bits, okay, we have the colors, okay, they're going to be color coded, each entry or each win. And then you have the bit count, okay, the bit count, very simple. How many 1 bits are in there? So don't look at this. This is just an example. This is not correct. It's not the actual numbers for these, but it would be like 2, 3, 4. It would be 4, 5. Be 4 here, 3 here, 3 here, 2, 3, 4 here, right? So you'll be able to tell which one may come out first. So if you have like 1, 1, 1, then you know 1, 1, 1 is not going to, a low probability is going to hit next. So you can remove those. Okay, and I'll show you why that's important. Um, and then here with the bits. So look, it's going to look like this, the filter, or work with this. Look, it's going to work with the bits, not that. Hold on. There you go. So it's basically, here's the filters, right? I needed to add the count, whatever, you saw it. So, okay, so here it is. So 0, 0 equals 0, 4, 8, 0, 1 equals 1, 5, 9, 10, 1, 0 equals 2, 6, 1, 1 equals 3, 7. And it's like this. You got 1. They all start with 0. The first group starts with 0. The winners start with 0. Second group starts with 1. Third group starts with 2. Excuse me. Third group, and then fourth group starts with 3. Okay, but if you see the second number on it, look. You have 0, 4, 8, 1, 5, 9, 2, 6, 3, 7. So you do have all the low numbers and high numbers. 0, 1, 2, 3, 4. You got 5, 6, 7, 8, 9. So you have it all. It works out great. And here's how the counts are. Here's the real counts, okay? So look, 0, 1 bit, right? And there's 1. 1 bit, there's 1. 2 bits, there's 2. 1 bit, 1. That's how it works, okay? And they're color-coded like this. So for example, if you believe the next winner is going to be, you know what, let me bring that back. If you think the next winner is going to start with a 0, then you know you'll start with this group, okay? And then depending on what came out in order, right? Hold on, let me just do this. Okay. Depending what came out in order here, all right? You see blue or green. You think blue and green may come out as well. One of them may come out again. But you think it's going to be with a 0. So then here's the 0 group, the first group. And then here's the blue, okay? And then here's the green. These two here, where you think. But if 1, 1, 1 was coming out, you know, in a row, say 2, 2, 2, 2, 2, 2, 2 came out 3 or 4 times in a row, right? Then you think the only one, if you're going to do blue or green, the only one is going to be rows 1, 3. Rows 1 and 3 in the blue and the green. So it'll be just a few numbers you'll be able to know. It'll be these bits like that. Okay? These here. See that? Right there in that those rows. And you can remove the rest. Okay? And what it's going to do is, you saw the 10 numbers, right? So you're able to get this down to 10 numbers or 9 numbers. By adding the bit filter, you're going to be able to get this down much more. Okay? That's what we want. Okay? So when you're playing here, you don't have to just play, the pink. You could play the brown. You could play all of them. And you'll be playing with less than 10 numbers. That's where I want to get you to, where you play all of them, and you're playing all these patterns, and you're only playing less than 10 numbers, okay? That's where I want to get you down as much as possible. Now, I want to talk about, all right, I'm going to talk about quickly the mobile app, and then I'm going to talk about the quantum filter that I'm working with the physicist on, okay? All right, quickly. A review of the mobile app. The design is completely done, all right? And we are just attaching all the codes to it from the mobile web page. And you're going to be able to get something like this, okay? And it's going to be really cool. You're going to be able to get the numbers down just like I showed you on the web page. And then we're going to add the filter here for the bit filter. And if everything goes well with the quantum filter, okay, the qubit filter, we're going to add that as well. And it's going to take it down to like 1, 2 numbers, okay? Let's see how it turns out with the physicist and how it comes out with everything. I was testing the mobile, just to jump to something here. I was testing the mobile web page today, and I was winning. Easy. easy wins. Okay, I was utilizing the filters. Okay, I just picked a few. Okay, that tend to come out a lot, and gave me like 12 numbers for this page, color green, and one. All right, and again, another win. Okay, these are 24 numbers, another win. Let's see, okay, another 24 numbers. All right, so we want to get those numbers down, down, down. All right. Now, let's see with the mobile page. The mobile page, just I want to mention something. Jumping back, we are putting these drop downs here. Okay, so you'll be able to filter these out, the chart, so you'll be able to see what the correct patterns are. And also, we're putting the calendar on here as well. Okay, so you'll be able to see what the calendar is. We're doing a video tutorial, so it's going to explain everything how this is works. It's very, very simple. 3 questions mandatory you need to ask before numbers are shown to you, and then you have 3 filters that are optional to help you reduce them more. Exactly on the web page, you see that exactly like these, okay, filters, and then we're going to add another one, which is going to be the bit filter, and hopefully we can add one more, which is going to be the quantum filter, which is the qubit filter. All right, so we got the bits, and under the bits, we're going atomic level here. This is serious stuff. Okay, let me talk about that now. Let me talk about the quantum filter. This is crazy. Okay, if anyone knows, if you know about quantum physics, we're dealing with qubits. Qubits create waves, okay? Waves create patterns, interference patterns. Okay, I'm not going to get into this very much because if this thing works, I want to patent it. Okay, and if I start spilling the beans right now, then my competitors will definitely jump on this. Okay, but just to let you know, it takes a certain method we utilize with Lottodds that's successful in reducing numbers. It applies them to quantum filters. We're applying them to the quantum, I should say, qubits. Okay, and if it works like we think it's going to work, we're going to get these numbers down to 1, 2 numbers. Okay, without losing the winner. Okay, that's what we think by utilizing, looking at these qubit waves, okay, with the interference patterns, okay, we're going to be able to reduce these numbers even more without removing the winner. All right. Now, lastly, I want to talk quickly about the artificial intelligence. If you guys don't know what the artificial intelligence is, and you have never tried ChatGPT, you're missing out. This thing is truly, truly artificial intelligence. This thing thinks and responds to you like a human being. Um, it's Look at it this way. Google, you enter keywords, right? And it just matches your keywords to keywords on websites and stuff, right? And it shows you a display. This is totally different. AI, you ask it a question, it will get deep down. In these, you know what? Hold on. Let's see here. Let me show you an example. Chat GPT. So I could show you what we're going to do with this thing. All right, here. Explain real quick. Simply explain in layman terms. Explain qubits. All right. That's simple.
In simple terms, qubits are the
Hold on.
computers, similar to bits in classical computers.
Hold on.
In simple terms, qubits are the basic units of information in quantum computers, similar to bits in classical computers. However, unlike bits, which can be either 0 or 1, qubits can be in a state of 0, 1, or both at the same time, a property called superposition. This allows quantum computers to process a vast amount of information simultaneously, potentially solving complex problems much faster than traditional computers. Additionally, qubits can be entangled, meaning the state of one qubit can depend on the state of another, no matter the distance between them, which enhances their computing power.
Now watch this. Now hold on. Can qubits create? Hold on. You have to know what to ask it. Can qubits create matching? Can qubits create matching waves through their interference? No, through their qubit waves. Sorry. Okay. Can qubits create matching interference patterns? You have to be very specific. Can qubits create matching interference patterns through their qubit waves? Okay. There you go.
Yes, qubits can create matching interference patterns through their wave-like properties. When qubits are in superposition, their probability waves can interfere with each other, much like waves on water. This interference can enhance certain probabilities and cancel out others, which is a fundamental principle used in quantum computing to perform calculations and solve complex problems efficiently. Yes, matching interference patterns in qubits can create a high probability of a specific outcome. By carefully controlling the superposition and interference of qubit waves, quantum algorithms can amplify the probability of correct answers while minimizing the probability of incorrect ones, effectively steering computations toward the desired solution. This is a key principle behind the power of quantum computing.
And there you go. You got your answer. You see, that answer, that method is what we're going to utilize to create this quantum filter for lotto odds. But we're going to implement our method that we're using successfully on lotto odds, okay, with it to come up with the desired end result. And the desired end result is to take these 9 numbers and to take them down to 1, 2 numbers. That is what we're working on. That's why I hired the physicist. Okay? So you have your answers there with these waves that we're going to be working with qubits. This is crazy. This is wild. And as for the artificial intelligence, what we're going to be doing is we're going to give you just saw what artificial intelligence can do, right? So it specifically answers you, right? Well, we're going to take all the code source of lotto odds, feed it into AI, train it, okay? So you'll be able to utilize it to ask it any questions. Okay. Oh, what is this for? What is this feature for? What is that feature for? Can you tell me the best filters to utilize to get the best result for the next draw for this state? Or could you tell me give me 3 numbers to play that have the highest probability of winning for the next draw, like that. It's going to be able to answer anything that you ask it pertaining to lotto odds. Okay? Complex questions dealing with each and every filter. If you combine filters together, one of the wild things about what we're going to do is we're going to add AI with quantum computing. And what's that going to do? For example, right now with classical computing, it takes it one at a time, the filter. If you want to do a specific task, right, it'll take it one at a time, one at a time, one at a time, right? But with quantum computing, it will do it all at once, right? Everything's done at once. So if you tell it, okay, I want you to combine these 5 filters or these 6 filters, get me a result, it will get you under a second a result, okay? And it will do that better than you could do it yourself. If you were here and you wanted to determine what are the best filters to add together to get the best result or specific result, okay, you might get confused after 4 filters, after 5 filters, or whatever, okay, or it might take you very long. You ask AI, okay, combined with quantum computing, okay, to do that for you and get the best result. It's going to take all the filters, make a computation of all of them, give you the best result right there. And you can do it verbally. In addition, it has visual, okay, visual feature, meaning you can connect the, click it, give the option for it to see what you are doing, to follow you as you go through the filters and you point to this. Oh, what's this? Or what's that? What if I do this? Or what if I do that? Come here. Okay. And then you could, for example, here's a good example. You could go through the filters, and then when you get a certain result, you could say, you saw what I've done. Why did I get this result? And then it'll explain to you in detail why you got that result. And you could say, oh, I think this is wrong. Is this wrong? Is this a fault? And it could say, no, it's not a fault because you've done this and you've done that, and that's why you got that result. Okay? In addition, it's going to help us make sure all the code is functioning properly and that there's no error in the code, and also how to efficiently code certain features and functions. Okay? This is huge. And we're going to be moving into the future with this, okay? Nothing like it exists, all right? I'll let you know about the mobile app. We should be done with it soon. I will let you know. We've had some delays, but it should be done within a week, okay? I wish you the best.